Alright, for today's lesson, we starting chapter 8 now, and our goal today is to simplify rational expressions. Now, what a rational expression is basically any expression that looks as basically it's a fraction, it's a polynomial within a fraction. Now, we're going to start off by simplifying these, and then later on we're going to multiply and divide them. When you're simplifying, remember some of the basics on simplifying. Like 8/12. If I want to simplify that fraction, I can factor 8 completely. That's 2 times 2 times 2 over 12, which is 2 times 2 times 3. And cancel out common factors. There's a pair, and there's a pair, and we multiply what's left over. That's 2/3. Okay? Same procedure would work over here with these rational expressions. You want to factor them completely, similar to this, and then cancel out the things that match. We'll start off here with this example number 1. Alright, step 1, I need to factor this completely. Now on the top here, I've got 5x. That's just 5 times x. But now, x squared plus 4x plus 3 is going to factor into two binomials. Alright, I've got the x's in the first place. The plus tells us that we're going to have the same signs in both parentheses, and since they're the same, this symbol will tell us what they are. We're going to put a plus and a plus. Now I think of two numbers that multiply to get me 3 and add to get me 4. Of course, we've got 3 and 1. Now I'm going to factor the bottom. The first one's already factored, x minus 6. Since it's a first degree, in other words, the x doesn't have power other than 1 on it, I can't factor any further there. There's no common factors. So this isn't anything like 2x minus 6. It's just x minus 6. I'll go ahead and factor that second one out. And when you're doing stuff like this, just remember this is similar to saying x squared plus 0x minus 9. So when I'm breaking this apart, I'll have an x and an x. This symbol tells us that we're going to be putting different signs in the parentheses, 1 plus and 1 minus. Now I try to think of two numbers that multiply to get me 9 and subtract to leave me with nothing. Of course, it's 3 and 3. Okay, now at this point, get that sound turned off there. I can go through and start canceling things that match exactly. I've got a 5, but there's no single 5 here. I have an x, but there's no single x here. I've got an x plus 3 that matches this x plus 3. I can cancel there. And then I've got an x plus 1, but there are no x plus 1s down here. So I've canceled everything I can, and now I need to remultiply everything. 5x times x plus 1. So that's going to be 5x times x is 5x squared, and 5x times plus 1 is plus 5x. That's going to be my numerator. Now we'll do the denominator. Just use your FOIL method here, and that's going to be x squared minus 3x minus 6x, so minus 9x, and then plus 18. Okay, in the second part, very important when we're solving equations involving these rational expressions, under what conditions is this expression undefined? Remember, zeros and denominators are not allowed. We want to be sure to look at the original problem. All right, so here x could not equal 6. Here x could not equal negative 3. And here x could not equal positive 3. All right? Okay. Now let's take a look at the next example. All right? This one's going to involve a little trick that we need to use a -1 to simplify with. We're going to go ahead and factor everything completely, and then we'll go through and make everything match, or make a lot of things match. Okay, so I'm looking at this first one. I see a 4 versus a 3. There's no common factors there. This is a w squared, and I've got a w. I can factor w out of both of those. Okay, and there's no y, so I can't factor y. So when I factor w out of both of these terms, that's going to be w times 4w minus 3y. Okay, and then I have just a w plus y. No common factors in that binomial. All right, let's jump down and take a look at the denominator. I've got two binomials, neither will require any factoring. There's a y versus w, nothing there, 5 wy. So this is where we're at after completely factoring this one. Now notice, this says 4w minus 3y. This is 3y minus 4w. If I can force the signs on one of these to be different, like if I make this a negative 4 and a positive 3, then they'll match. So what I'm going to do here is I'm going to factor out a negative 1. All right? I'm just going to stick it in front. I'm taking the negative 1 out of this one. All right, that's going to make that 4w negative and the 3y positive. I can rearrange it now. It's going to become positive 3y minus 4w. And so over here I've got my w plus y from this problem right there. And my denominator, 3y minus 4w times 5w plus y. And now I can go ahead and do my canceling. Negative 1's not going to cancel. W's not going to cancel. 3y minus 4 will cancel with that one. Notice, had I not taken out the negative 1, they wouldn't match and I couldn't cancel. That's w plus y. I see you've got a w plus y right here, but it's an all or nothing thing. If I can't take all of it, I can't take just part. So here, since that's not an exact match, I can't cancel those out. And that's going to get my final answer now of negative 1 times w is negative w. So I've got negative w times w. That's negative w squared. Negative w times a positive y is minus w y. And my denominator is just this one right there, 5w plus y. Okay, now let's move on to my next example here. Multiplying and dividing. The same rules that apply for multiplying and dividing with fractions apply for the rational expressions. Okay, top times top, bottom times bottom, but sometimes it's easier to factor these and cancel before you multiply. So 2 is 2, 15 is 3 times 5, 9 is 3 times 3, 4 is 2 times 2. Cancel what you can, re-multiply what's left over, and you get the answer. Division, just remember your rule. We're going to change from divide to multiply, and we're going to flip this fraction over. And then we'll do just like we did with multiplication. So I've got the rules apply for the expressions, the rational expressions as well. So let's take a look at this first. Okay. All right, I'm going to break everything apart completely. 6 is 2 times 3. I've got a c. Okay, now I'm going to go over here and get this one broken apart. 15 is 3 times 5. And I've got a c. And then a d squared, so that's d times d. Notice it's multiplied, so I'm going to be multiplying. That's the numerator. Now for the denominator. 5d. I can't do much breaking apart there. 8a. 8 is 2 times 2 times 2, or 2 to the third power, times a. Top times top. Bottom times bottom. Now cancel. 2, 2. 3, no 3's. C, no C's. Check the 3's already. There's a 5 that can go with this 5. There's a D that can go with this D. There's another D, but there's no other D's down there. So what do we got left is a 3, a C, a 3, a C, and a D. On the bottom, I've got 2, 2, and A. Now I simply remultiply what's left over here. 3 times 3 is 9. 2c, that's c squared, and a d. There's my numerator. My denominator is 4a. Okay? All right, that's the multiplication of an expression. Now let's take a look at a division of an expression. Basically, before I do any work on this, I'm going to go ahead and flip and multiply. So 18x y to the third over 7a squared b squared. Change to multiplication. Flip the second fraction over. 35a squared b over 12x squared y. Now break everything apart. All right, 18 is 2 times 3 times 3. Then I've got an x. I've got a y to the third. Okay, on this one, 35 is 5 times 7. A squared. B. There's my numerator. Now let's go to the denominator. 7 is prime. A squared. B squared. 12 is 2 times 6, which is 2 times 3. X squared. And y. And now I'll go through and cancel. All right, 2, 2, 3, 3. No more 3s. All right, it's going to be left over x, x, y, y. There's a couple more y's left over here. 5, and no 5's down there. 7, 7, A, and A, A, and A, B, and B. So what's left on the bottom looks like not a lot. Now we'll go ahead and multiply top times top. 3 times 5 is 15. Y squared over 2bx. Okay, so notice when we factor, we break everything apart completely. Now that carries over into your rational expressions like this one. We want to factor everything completely. So on the top, just like we did with the previous example and simplifying a couple examples back. All right, so 2 parentheses, x's. Okay, now the signs in the parentheses are different because that's a minus. 2 numbers that multiply to give me 16 and subtract to leave me with 6 are 2 and 8. The 8 will go with the minus, and the 2 will go with the plus. All right, now let's go ahead and bring this other one over. This numerator is just x minus 8. Cannot factor anything there. All right, let's jump down here to this one. That one is a perfect square trinomial. All right, both minuses. And I need 8s. Okay, this one. Okay. The signs within the parentheses are the same, and they're both plus. All right, how about 2 times 3? Now, once we've done all that, we can cancel and remultiply. There's an x plus 2 and an x plus 2, an x minus 8 and an x minus 8, x minus 8 and another x minus 8. Now notice everything in the numerator is canceled out. So I'm going to put a 1 there. On the bottom, all that's left is x plus 3. And there we go. It's multiplied, simplified, ready to go. But with division, just do a division problem that's like this, similar to this division problem right here. All right? That's all we have for the lesson today. Hopefully, we'll have school tomorrow because of the snow.